In the previous lesson, we discussed the typical cash flows we must plan when performing a capital budgeting exercise. And that's a solid foundation that brings us one step closer to performing a sophisticated capital budgeting exercise. However, to do that, we must be able to forecast each item and create a numerical simulation of the insights our team has about the project. First, we must estimate the actual investment needed for the project. Depending on whether we plan to build a plant, invest in IT, or something else, we must make sure we have a good idea about the money needed to complete the project. Things become easier if we sign a contract with a third party and they bear the risks associated with cost overruns. Otherwise, if we invest in building a new facility and construction becomes more expensive than initially thought, the entire project assessment we have prepared with the capital budgeting exercise becomes irrelevant. So it is key to understand whether the initial investment is a fixed amount or an estimation that will likely change once the project starts. If we are in the second scenario, we should perform a sensitivity analysis that would allow decision makers to see how the project's financials will look in different states of the world, like creating different scenarios in which the plant we are building costs different amounts. Once the project has been completed, it will serve its purpose. In our example from earlier, the plant will produce bicycles and generate money. How much, though? Well, here's the tough part. We must estimate how much money will be made before the project starts. This involves assessing the demand for bicycles and making an assumption about the price at which they will be sold, not only a year from now, but throughout the life of the entire project. By estimating the potential demand and the price at which the company can sell bicycles, we'll obtain a projection of revenue figures. Then comes the matter of estimating expenses. Here, we can have plenty of unknowns. The price of bicycle parts our plant uses could change. Cost of labor increases over time. Plus, there can be other unexpected factors along the way. The important thing is to model expenses in sync with revenues and respect the assumptions we've made when forecasting revenues. Most practitioners prefer modeling COGS and OPEX costs as a percentage of revenue. And this can be a potentially viable approach, especially in the long run. When we must forecast 5 or more years ahead, it is difficult and impractical to do it for each line item. Right. Once we've modeled revenues and COGS, we must think about the cash flow effect that will derive from balance sheet items. We already said working capital investment will likely represent significant cash tied up into the project. Inventory, trade receivables, and trade payables are 3 items we must consider. The days technique we studied earlier would allow us to forecast these items in line with revenues and COGS we've assumed earlier. Depending on the project your company is working for, you may want to consider the impact of other balance sheet items too. For example, in certain legislations, we could deduct certain costs earlier, which will give rise to deferred tax liabilities. If so, and the amount is serious, we should take deferred taxes into consideration when coming up with cash flow estimations. At this point, we've estimated all P&L and balance sheet items necessary for calculating recurring cash flows. And this takes us to the end of our project, when we can expect 2 types of inflows. One deriving from selling the residual assets related to our project, and another from the freeing up of working capital. The terminal disposal price of the asset we've invested in is determined by its degree of obsolescence. If this is an asset that ages quickly, then the terminal price will be a small fraction of its original price. However, it is also possible to have an asset that is still valuable and can be sold at a good price. Usually, companies use the services of specialized personnel who can value such assets and come up with a concrete value. For your reference, in some models, terminal value could be as low as 3 or 5%, while in others, it can be even 40%. It depends on the type of asset we are considering. The estimation of working capital freed up at the end is easy. We've projected working capital values until the end of the project's useful life. The amount of capital that will be freed up at the end is the same as the amount of capital we used in the last year of projections. Okay, great! This is how we come up with the numbers that would allow us to carry out a proper capital budgeting exercise. Thanks for watching this lesson.